Hello and welcome back to yet another episode. Myself, Fazira Zak Hamza, Assistant Professor in PGA Department of Computer Science, and I'm here to present on the course Principles of Software Engineering. So in the last class, we were discussing about eliciting requirements and developing use cases based on some scenarios. Today in this episode, I'm going to discuss on building the requirements model. So the intent of the analysis model is to provide a description of the required informational, functional, and behavioral domains for a computer-based system. The model changes dynamically when we learn more about the system to be built and other stakeholders understand more about what they really require. So, the requirements model is always evolving. As the requirement model evolves, certain elements will become relatively stable, providing a solid foundation for the design tasks that follow. So, the analysis model and methods that are used to build the model are presented. So, let's see. First is the elements of the requirements model. There are many different ways to look at the requirements for a computer-based system. So different modes of representation of the requirements force to consider requirements from different viewpoints, that we already know that different customers have different viewpoints. So the specific elements of the requirement model are, first one is scenario-based elements. The system is described from the user's point of view using a scenario-based approach. So, scenario-based elements of the requirements model are often the first part of the model that is developed. They serve as an input for the creation of other modeling elements. Now, let's see what is scenario-based elements using a figure. This figure I've already explained in the last episode for high-level use case model. The figure depicts a UML activity diagram for eliciting requirements and representing them using use cases. So, 3 levels of elaboration are shown here about a homeowner, system administrator, and also the 3rd level of elaboration is the sensors. A next element of the requirements model is class-based elements. Each usage scenario implies a set of objects that are manipulated as an actor interacts with the system. So these objects are categorized into classes, means a collection of things that have similar attributes and common behavior. So now let's see the figure. This is a class. We have a class name, then attributes and functions. So figure shows the UML class diagram which depicts a sensor class for the same safe home security function. The diagram lists the attributes of sensors. Attributes are name, type, location, area, characteristics, and the operations, that is identify, enable, disable, and reconfigure, that can be applied to modify these attributes. A next element of the requirements model is behavioral elements. So let's see what is behavioral elements. So the behavior of a computer-based system can have a profound effect on the design that is chosen and the implementation approach that is applied. Therefore, the requirement model must provide modeling elements that depict the behavior. So here, the state diagram is one method for representing the behavior of a system. How is it doing? It depicts its states and the events that cause the system to change state. So we can say a state is any externally observable mode of behavior. So state diagram indicates actions, for example, process activation, taken as a consequence of a particular event. So a simplified UML state diagram is shown here. Here a software is embedded within a safe home control panel that is responsible for reading user inputs. So the first compartment consists of the state name, then the state variable, whether it shows ready or steady or enter the command. Then we have state activities which performs certain actions. Our next element of the requirements model is flow-oriented elements. Here, information is transformed as it flows through a computer-based system. So, the system accepts input in a variety of forms and applies functions to transform it and produces output in a variety of forms. So, input may be a control signal transmitted by a transducer, a series of numbers typed by a human operator, a packet of information transmitted on a network link, or a voluminous data file retrieved from secondary storage. The transforms may comprise of a single logical comparison, a complex numerical algorithm, or a rule inference approach of an expert system. Output may light a single LED or produce a 200-page report. So here the figure shows the UML activity diagram for eliciting requirements. So we have the first part, that is elicit requirements. Here it is the elicit requirements. Then we conduct meetings, make list of functions or classes, make list of constraints. Then if the prioritization is set, we will send it to the QFD to prioritize requirements. Otherwise, we will informally prioritize the requirements. Then after prioritizing the requirements, we create use cases of the same. So by drawing use case diagram, we define actors, write scenario, and complete the template. This is how a UML activity diagram for eliciting requirements look like. Okay. Now we are moving on to our next topic, that is negotiating requirements. We can enter into a negotiation with one or more stakeholders, right? In the last episode itself, I said there were maybe so many stakeholders, so we can enter into negotiation with more than one stakeholder. So in most cases, stakeholders are asked to balance functionality, performance, and other product or system characteristics against cost and time to market. So the intent of negotiation is to develop a project plan that meets stakeholders' needs while at the same time reflecting the real-world constraints. What are the real-world constraints? Time, people, budget. Okay, these are the real-world constraints that have been placed on the software team. So the best negotiations strive for a win-win result. That is, the stakeholders win by getting the system or the product that satisfies the majority of their needs. And we as a member of the software team win by working to realistic and achievable budgets and deadlines. So, negotiating requirements defines a set of negotiation activities at the beginning of each software process iterations. So, rather than a single customer communication activity, the following activities are defined. Let's see what are the activities. First activity is identification of the system or subsystems key stakeholders. Then determination of the stakeholders win conditions. Then negotiation of the stakeholders win conditions to reconcile them into a set of win-win conditions for all concerned, that is including the software team. So successful completion of these initial steps achieves a win-win result, which becomes the key criterion for proceeding to subsequent software engineering activities. So after negotiating, we are moving on to the next step, that is validating requirements. So as each element of the requirements model is created, it is examined for inconsistency, omissions, and ambiguity. So the requirements represented by the model are prioritized by the stakeholders and grouped within requirements packages that will be implemented as software increments. So therefore, each requirement and the requirement model as a whole are validated against customers' need to ensure that the right system is to be built. And a review of the requirement model addresses the following question. Let's see what the questions are. Questions include: is each requirement consistent with the overall objectives for the system or product? So, all individual requirements should be consistent to the overall objectives of the system or product. Then have all requirements been specified at the proper level of abstraction? That is, do some requirements provide a level of technical details that is inappropriate at this stage? So we have to specify all the technical detail during the abstraction of the requirements itself. Then next question is the requirement really necessary, or does it represent an add-on feature that may not be essential to the objective of the system? So we are checking for whether the requirement is necessary or not. Is each requirement bounded and unambiguous? Unambiguous means whether we are having a confusion or not. Then does each requirement have attribution? That is a source generally a specific individual noted for each requirement, whether each requirement is being provided from a proper source. Then do any requirements conflict with other requirements? Then is each requirement achievable in the technical environment that will house the system or product? And is each requirement testable once implemented? Then does the requirements model properly reflect the information, function and behavior of the system to be built? So asking such questions will validate all the requirements which we have been specified in the requirements engineering process. Then, has the requirements model been partitioned in a way that exposes progressively more detailed information about the system? Then, have the requirements patterns been used to simplify the requirements model? Have all patterns been properly validated? Are all patterns consistent with customer requirements? So this is today's topic. I have started with building the requirements model, and I have specified some key elements for building the requirements model. Then I have talked about negotiating requirements. Then after negotiating, I have validated the requirements with a set of questions. I hope you all understood. Have a wonderful day. Thank you. Thank you so much for listening.